All right. Well, let's just do this.
Recently, I've been trying to get into better shape, but I have one major problem. I love McDonald's. So in this video, I wanted to see if I could make a data science project that would help me find the healthiest food I possibly can at McDonald's and help me reach my nutritional goals. I want to eat the least amount of calories possible while still hitting my macronutrient goals. So to solve this problem, we're going to use a mathematical technique called linear optimization. It's basically used to find the best possible outcomes for these types of problems. And in this case, we're trying to find the optimal food.
Bro, then why isn't do they teach linear optimization when they're teaching personal trainers? Because if this is like the most typical, easiest, optimized way to do something, by the way, also linear, which for the data scientists in the chat, I know what you're thinking. Linear? Is this the most linear way? Is a linear way the way?
Combination. These linear optimizations or linear problems are usually set up like this. There's something that you're trying to minimize or maximize, whether that's...
This is like a knapsack problem.
Minimizing calories. And there's a series of limitations or constraints that don't
where we at?
That optimally. And you have to stay within inside those constraints. For example, in this case, we have to stay within our protein bounds of 45 and 65 grams of protein. We can't hit a certain level of sugar and a couple other nutrient constraints. Using linear algebra, we can set up a mathematical model for this situation and use math to find the optimal outcome staying within the constraints that we give this problem. So I already know what I want to minimize. I want to minimize calories, and the different constraints I'll be looking at in this particular exercise are the fat, the saturated fat, sugar, protein, the carbohydrates, and the sodium. So we'll have limits.
Where's the alcohol?
Limits that I've chosen kind of arbitrarily right here. Now these aren't necessarily arbitrarily. They're taken from the government's websites and their suggestions, but mix and match for your own diet and your own life.
But we've seen the graphs like this, right? Like the government recommendations here. Typically, the food pyramid is saying you should eat this percentage of fat, oil, sugar, and sweets, this percentage of meat, fish, milk, eggs. This is essentially your protein. In terms of your fruits and vegetables, this is mostly... When you subtract the vegetables in terms of caloric intake, you're talking about nearly only sugar, and then the rest is fiber, and then a lot of carbs. But if you take the same pyramid and you use it for actually what the what you need in terms of each of these food groups, like a protein group, your sugar group, your fat oils group, and then ultimately your carbs group, like... This is extremely disproportionate. So your USDA food pyramid is actually, surprise, is actually propaganda. Why is it propaganda? Because in each of these layers is actually this. Oh shit, I can't zoom in anymore. It's actually corn. It's corn. Corn is not just a vegetable. Corn is in your cereals. Corn is in your sweet sugars. Corn is in your fats and your oils. Corn is in your dairy. Corn is in your preservatives for your fish and your meat. Not only lobbyists and politicians' favorite vegetable, but it is America's favorite vegetable. It is Monsanto's favorite vegetable. It is the vegetable in America, corn, because it does so much for us. Okay, back.
Lifestyle. Next, we need data, and before I show you where I got this awesome data set, I want to tell you this project was actually taken from my friend Kyle Pastor, who wrote a great Medium article about this project. I included this project inside of my course as a really good example of the creativity and the thoroughness of what a project can actually look like. If you want all the resources that I use to make these projects in 30 days, you can check out my
what's up?
Science Project Studio, which is the best way to build your data science project and portfolios. I also have a link to Kyle's Medium article below in the description. So here's the data set for the nutritional facts for McDonald's menu. It is just on Kaggle. We can go through, see all the different...
I like how Avery was like, oh, this data set is secret. I'm going to tell you where it is soon enough. And it's just on Kaggle.
Columns.
Nice.
And basically what it is every item that they have on their menu and the serving size, the calories,
Me?
fat,
I'm too dank.
saturated fat, cholesterol, all the nutritional values that you might need to know are in here. So go ahead and hit download so you have that as a CSV. Now, I not only wanted to give the option to find the healthy.
I was yelling. Have you been in this stream for longer than a week?
With your different macronutrients and what you're trying to do in your life. So I didn't want to keep this on my own machine and only make it my constraints. I wanted to open this up to the web and turn this into a product. And so I used Streamlit to create this awesome dashboard tool that basically allows you to input your different constraints, and it'll tell you what the McHealthy combo is best for you. Now, the code to write this is a little bit complicated. It took me about 150 lines of code to create this Streamlit app that does the McHealthy combo optimization. But basically, here's what you need to know. I'm using a library called Pulp, P-U-L-P. That is a linear program Python library that lets you set up these types of linear optimization problems. This section of the code right here is where I set up that linear problem inside of Pulp in Python. You can pause the video, kind of read through what I did. It is a little too much complicated to explain right now in this short video. A good chunk of the rest of the code is actually just building the Streamlit app, which is really easy to build. It's just a couple lines to basically take in the sidebar, to have the header at the top, and to display the graph kind of on the bottom right hand side. And here is the app. You can go to this URL right here to try it out for yourself. But you can see that the optimal McHealthy combo for me personally is 2 apple slices packages, 5 side salads, 5 fruit and maple oatmeal with brown sugar, and 2 large diet Dr. Peppers.
What gives you the calories here? 5 side salads, apple slices, 2. Wait, data science said do this? Did I miss something? Hold on. So he has a Streamlit app, and if you put in your constraints, so in this case, maxes and mins. So this is just telling you here, like, how do you get kids French fries? Oh, this is the count. So if you have apparently 1,700 orders of French fries, kids French fries, you're gonna get 83,000 calories.
What the McHealthy combo is best for you. Now, the code to write this is a little bit complicated. It took.
Is it complicated? Where's McData? Oh, it's the CSV. To list. Okay. Oh, the item column. Then you send the next item to list to dict. So you just ripping out. Wait, then why did you bring it in as a CSV at all? Why did Avery set index item on all of these? Why didn't he just read CSV index equals item? Index call equals 1 or 2 or 0, whatever the fuck column item is. Why did he do this? And then why did he convert all macronutrient fields to be dictionaries of item names? Why did he convert every column into a dictionary? Oh, it's because of the... Is it because of this? Is it because of the thing he was trying to solve for? It was LP problem. Well, where the fuck is LP problem? Is that what he was trying to solve for?
It took me about 150 lines of code to create this Streamlit app that does the McHealthy combo optimization. But basically, here's what you need to know. I'm using a library called Pulp, P-U-L-P. That is a...
Oh, P-U-L-P. Oh, that's the linear problem. This is the linear shit.
Linear program Python library that lets you set up these types of linear optimization problems. This section of the code right here is where I set up that linear problem inside of Pulp in Python. You can pause the video, kind of read through what I did. It is a little too much complicated to explain right now in this short video. A good chunk of the rest of the code is actually just building the Streamlit app, which is really easy to build. It's just a couple lines to basically take in the sidebar, to have the header at the top, and to display the graph kind of on the bottom right hand side. And here is the app. You can go to this URL right here to try it out for yourself.
Yes, this one right here, very easy to type in. This is Avery data dash McHealthy dash optimized tool dash V9I1 U8. Yeah.
but you can see that the optimal McHealthy combo for me personally is 2 apple slices packages, 5 side salads, 5 fruit and maple oatmeal with brown sugar, and 2 large diet Dr. Peppers. If I ate that for the whole day, that would be a total of 1370 calories. And that is how I can hit my macronutrient goals in the least amount of calories, the healthiest way, by going to McDonald's for all 3 meals. So I'm kind of hungry. Let's go test this out. Hi, yeah, I was doing some research on what the healthiest stuff here is. So I was wondering if I could have, do you guys have a side salad? Can I have an oatmeal then? Do you guys have apples? Okay, I'll have a thing of apples as well as a large, no, we'll just make it a small Diet Coke. Thank you. So I hope you guys enjoyed this project. This was day 28 of building 30 data science projects in 30 days. And I have all of the code available for free for you guys in the description down below. There'll be a link that says resources, just click there. Not bad. If you enjoyed this video, go ahead and hit subscribe so you can see more projects. Thanks for watching, bye.
I'm just gonna say this about this video. The first thing I'm gonna say about this fucking video, dude. Avery, by the way, I love you. I love you, bro. I love you. Clearly, a lot of different Python tools that were involved in this one. So I cannot fault a dude who's just trying to do his best in terms of Python. He wants to create a Streamlit app that ingests a Kaggle data set that allows ultimately anyone to produce whatever fucking meal they want. But the thing is, right, the issue with problems like this, when you take it out of the box, just like you're doing, even though you're trying to maximize or minimize certain things, the fact that your rigidity in all of these things is a specific set. When you have like rigidity in terms, and like I don't necessarily know if this is what was happening, but when we looked at the app, like total fat max, right? And then you're having a 70, right? That does mean when you get to the code, which you see a limit for combo, and you have hard coded values down here, and I don't necessarily see get the code and the data for this project here. Okay, let's comb through it. Give me the, oh god, Jesus fucking Christ. When you get confronted with code and it has some weird hard coded values in there, and when we see that the actual app that you created, it has maxes and mins, really what you're doing is your bounds are too rigid, right? And that's why you end up coming out with like weird ass meals, like, oh, let me go to McDonald's and order apple slices, a salad, a large Diet Dr. Pepper, and oatmeal. Like that's when your shit starts getting weird, dude, right? Like that's weird. That's like when the initial Dolly, the initial like the generators first started taking on like open beta people, and they typed in like monkey and they came out with like weird shit, right? It's like, oh, this is some strange things. And there was no iteration over like making that product better, right? Like if you are ultimately creating a product that, or ultimately creating a menu optimizer that's supposed to literally optimize a menu for a customer to optimize calories, but also optimize experience, this is lacking the experience side and maximizing on the calorie side, right? And if someone was thinking, let's go to McDonald's, no one's thinking of this, right? As a person who literally worked for a fast food chain before, when we're trying to optimize for health or for whatever thing, the number one thing is, does this have our identity? And when we talk about McDonald's, this has zero McDonald's identity. Even in this, though, which is actually surprising. is when you actually get the oatmeal and the Coke, you still have McDonald's marketing on here. That is actually impressive. Because at the end of the day, so long as your logo is out there and people are seeing it and enjoying it, you're winning as a brand. But is this guy winning?
Description down below, there'll be a link that says resources. Just click there.
Does this face, where the fuck is it? Playback speed, half.
There'll be a link that says resources. Just click there.
No.
There'll be a link that says resources. Just click there.
Does this face seem to you like a face that says, I'm gonna do this again? Eating his McCafe oatmeal, washing it down with a Diet Dr. Pepper. No, I don't think so either. Did two things that were actually really good and one thing that was really bad. The two things that were really good. One, it presented a problem and it answered the problem. That's the second thing. First thing, it presented a problem and they answered the problem. Avery answered the problem and that was really good. Those two things alone makes this a good data science video. Why does that make it a good data science video? Because they found a data set that allowed them to answer their problem, which was, I want to know what is the best way to make the calories at make the calories at McDonald's fit certain dietary restrictions. Not only did I find it, but I in fact made a Streamlit app. I in fact made an app, a web app that allows you to put in your own limits. And you're gonna get you're gonna get exactly the things you need out of this thing. But the one thing that they did bad was it was not humanized. Okay? It was not humanized. That's really bad. That's why people think data science is ruining the experience of users or customers or the product or anything that data science comes into contact with. Your objectivity blinds yourself to the subjectivity of human factors. And when I see a face like this eating McCafe oatmeal and washing it down with a fucking large Diet Dr. Pepper, and off to the side, you're chasing it with 2 slices of apples. This face is all I have to see to say, you know what? I don't think Avery is going to use this tool or go back to this restaurant ever again. And that's the issue. The issue is data science did solve a problem. But what it didn't help you with was all the other problems, like customer retention. Like, did this actually fit what our brand's message is going to be? Like, is this something we want to promote at all? And I'm not saying that Avery is bad. I'm saying Avery got to a spot that is unhumanized. Therefore, someone should make this better. Should Avery have made this better? In my opinion, yes. As a data scientist, as a content creator, no. I think you got enough here to have someone else sink their teeth into. Overall, like I said, beginning to end, you state the problem, you finish the problem. This is great. If I saw this on someone's resume, I have experience doing Python. Here's an end-to-end product that I built using open tools, open data set, and they showed me this, they might be at the top of my list in terms of technical candidates, because this is everything you could hope for. Data, a model, creating a model that fits everything together, taking that and turning it into a report, Having something that a user could use that's also interpretable and easy to understand. End-to-end product. That is truly what they called in the early 2010s a full-stack data scientist. As an entry-level person learning something from Avery and doing all these things, if you could do this on the fly off the top of your head, this was an easy thing to get to, mwah, you're doing great.